So first, to calculate the cross-sectional area of the sample, which is of course pi times the radius, which I'll calculate as the diameter, divided by 2, squared. And that gives us the area of the sample. I'll just reduce this one down to a whole number. And now for the next column, which is a simple subtraction, which is the values in the E column minus the values in the F column. And we can auto-fill this one down. And next, the coefficient of permeability as per the equation above. It's the volume, and this needs to be bracketed so it stays on the top of the fraction, times the length. Now we're going to reference this value several times as we go down the rows, so that cell will need to be locked, divided by, and we need the brackets in tight around the 3 terms on the bottom. Once again, an absolute reference for the area, because we'll use this as we go down the rows, times the time, and times the head difference, which I can't click because the formula is in the way, but I can see that we have here cell G15, so I just type that one in, close the bracket, and click enter. I can now autofill down. And I'll reduce this values to 2 significant figures as requested. Now I can convert the coefficient of permeability from meters per second into millimeters per second. Involves multiplying by 1,000, and we'll have 2 significant figures here. Now to generate the graph with the variables as specified at the top of the columns there. First variable we're describing as pressure, which is the area times the head difference, divided by the length between the tappings, and those 2 values need to be absolute referenced because I want to use the autofill function. And now for flow rate, which is simply the volume in millimeters divided by the time in seconds. I'm now in a position to plot the graph, which is simply going to be flow rate versus pressure. So highlight the 2 columns of data, go to the Insert tab, locate Charts, and directly above the term Charts is the XY scatter, and as usual for trend lines it will be scatter with markers. So both axes will need labelling. Now to add a trend line. In this instance, we're going to specify that the trend line goes through the origin. In other words, we set the y-intercept to 0 because 0 flow rate comes from 0 pressure. So understanding the physical relationship between the 2 variables, we know that this line must go through the point 0, 0. I'm going to remove the original trend line, which was y equals mx plus c, and just display the one that has the 0 intercept. Now we're going to use the slope of this trend line to estimate the coefficient of permeability. But possibly a better way to do this estimate is to actually calculate the average of the 4 measurements. So that simply equals average of all the members of the I column, and enter.